I want you to do this independently. You are just telling me if it's greater than, less than, or equal to. Remember, greater than opens up towards our bigger number. I'll give you 2 minutes and then we'll go over it. Tyson's all right, what do you notice is going on up here with these problems? So they're all multiplying by 5, something by 5, okay? And then something else happens. George and then Asher.
Well, less than 5,
Mm-hmm.
and then 5 times 8 is 87 is 187 away from being equal to, but like with B and C, it's 2 and 1/3, and there's still like a whole, and like C, 5 fourths, you can it as 1 and 1/4.
Mm-hmm.
So you're actually multiplying, you're not doing like what you're doing with the last.
Mm-hmm. Okay, Asher.
Yeah, I was gonna. Well, what I was gonna say was, if you multiply like a whole number by a fraction less than 1, it's gonna be less than average.
Yep. So if you take if you multiply a whole number by a fraction,
It's gonna be
your product is automatically going to be less than that initial whole number because you're finding a piece of that whole number. Okay. When we are multiplying a whole number by a whole number attached to a fraction, it's going to be greater than our initial fraction because we are multiplying by a whole number as well. Okay, so if we think of 5 times 2 1/3, we can think of 5 groups of 2 and then 5 groups of 1/3. 5 groups of 2 is going to get us 10, and then we're still going to have 5 groups of 1/3. So then we'll still have 5 thirds, which will again get us 2 more and then some thirds left over. So I just want you to think about it. Yes, sir.
For the ones like we're multiplying the whole number and fraction.
Mm-hmm.
You really don't need to worry about the fraction because the whole number is already here, and then you know that's going to be bigger than 2.
Yep. So if you have a whole number in front of your fraction, you're multiplying like here. Okay, we know it's already going to be greater than our initial number because we're multiplying by a whole number and then fraction pieces. So if you are multiplying by a fraction that is greater than 1, your answer should be greater than 1. If you are multiplying by a fraction that is less than 1, your answer should be less than that. Cool? Okay, because again, if we have a fraction that's less than 1, we're not multiplying by whole pieces. We're going to get smaller because we're just finding a part of that. Okay, excellent. Flip. Okay, so if we multiply 5 by 1, what's our product going to be? What does product mean?
The answer
to a multiplication problem. You got to have those terms locked up there. So 5 multiplied by 1 is going to get us 5. Okay. 12 multiplied by 1 is going to get us 12. 2/3 times 1 is going to get us
2/3.
6,789 times 1 is going to get us 6,789. Okay. 1,000,000 times 1 is going to get us
a million.
Okay. 1,000,000. So anytime you multiply a number by 1, it is going to give you that number. Okay. That is called the multiplicative identity property. Multiplicative identity property. You multiply a number by 1, it'll give you that number. It is its identity. Yes.
Can we just call it the MIP?
We can call it the MIP. Yep. Or the MIP. MIP. Okay. Multiplicative identity property. Okay. So, and I will make something to go up here. But if you want to jot this down somewhere on your paper, okay, 1, where's it right out? Times anything equals anything
One times anything equals
equals mid. So 1 times anything equals anything. Example, 1 times,
7.
we'll do, I was going to do a random big number. 3,
380 million.
okay, Oscar gave me one. 3,628 equals 3,628. 1 times 2 equals 2. 1 times 13 equals 13. I'm just writing 3 different examples down so you get the point. 1 times a number is going to give you that number. Tyson.
You can do like 1 times x equals x.
1 times x equals x. That would work too. I just want you to kind of have that written down somewhere. That is the multiplication identity property. MIP. Okay. So now we're gonna go through here. Display inflection marks. Yes. 1 times 13 equals 13. But you can do literally 1 times whatever, and it's gonna be that number. Okay, I'm gonna pull this back out because we have that information. Okay, so we're gonna draw this little chart here for ourselves. Okay, and this is my whole number. I want to write equivalent fractions for 1. So if I were to say 1 is my whole number, what are some equivalent fractions that I could say that'd be the same as 1? George, or Oscar, sorry. I don't even know why I said George. Oscar. 30 30ths. We can start that big, we can go a little smaller. What else would be equivalent to 1? Senna. Stay simple for the sake that we can get what's going on. 10 over 10. Tyson.
6 over 6.
6 over 6. Nolan. 9 over 9. Senna. 1 over 1. Okay, I'm gonna keep going. Chloe. 4,444 over 4,444. Tyson. 5 over 5. 0.5 over 0.5. 0.5 over 0.5. Senna.
1 octillion over 1 octillion.
1 octillion over 1 octillion. I'm not writing it. Ouch.
13 quadrillions, 698,745,102,023.
Over that same number.
Over 13 quadrillion, 698,745,102,023.
Okay. We could keep on keeping on, but we don't have time for it. Hey, I could keep going with 3 over 3. I could do 2 over 2. I could do 4 over 4. What do you notice about all of these fractions that I gave you? Alex, I need you to sit up, please. George.
The numerator and denominator are the same.
The numerator and denominator are the exact same. Okay. So finding equivalent fractions, I can start out just with 1, knowing 30 30ths, 10 tenths, 6 6, 9 ninths, 1 1. 5 tenths, 5 tenths, 3 3, 2 2, 4 4. Okay, all of these are equivalent fractions for 1. Okay, so it's just thinking about how can I take my numerator and denominator, multiply it by a different factor, and get equivalent fractions. Okay. So we wrote the names. You guys told me numerator and the denominator are the same. Why would it make sense that your numerator and denominator are the same for this equation here? Oscar, like for 1. Why would all of these make sense to be equivalent to 1? Start off with the question. What does this bar mean in these two numbers? A little bit more complicated for us. Divide. So is 9 divided by 9 1?
Yes.
Is 6 divided by 6 1?
Yes.
Is 30 divided by 30 1?
Yes.
Yes. That's your MIP. That's Ash. Yep.
D, I
Mhm.
So, like, you think about it, out of this many parts, you have all.
Yep. Out of this many parts, you have this many total. Or out of this many total, this is how many you have. We're saying we have a whole one here. We've got a whole one here, 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 so on, so on, so on. Okay, so you can almost think about it just as the same. 30 divided by 30 is 1. 6 divided by 6 is 1. Chloe, what you got back there?
Would it be
Yes, that'd be a division identity process. Yep. Number divided by itself is going to get you 1. Except it's kind of going the backwards way. Okay. So we're going to explore the results of multiplying fractions by fractions that are equivalent. It's going to be fun. Um, Remind me, how did we figure out how to multiply fractions in our last unit? What's that simple algorithm? What do we have to do? I know we went through all this coloring and shading and folding, but the easiest way to go through multiplying fractions is what, Nolan? Multiply your denominator by your denominator and multiply your numerator by your numerator. Straight across, straight across. There you go. Okay. We are going to do something similar here um, in multiplying fractions and finding equivalent fractions. So hopefully this table is what we need. It is. Excellent. Okay. So on this piece of paper, we kind of just went through. We're going to fill out 2 together. Wait, 3 fractions that are equivalent to 1. You pick them. I'm going to do 2 seconds, 4 fourths, 9 ninths. All of those are equivalent to 1. Hey, and then notice how over that equivalent fraction down here, they drew a little 1 to outline it. So you know that's an equivalent fraction. It means 1. Okay, use the fractions you wrote in part A up here to write 3 fractions equivalent to 4/5. Okay, so I'm going to take 4/5 times 2 halves. So 4/5 times 2 halves equals 8/10. Then do the same thing for the other one. So imagine I'm multiplying by 4 fourths. So then I've got 16/20ths. Then I'm multiplying by 9. Yes,
would 1 be 6?
because you've got 6 pieces out of 6 total. That would get you 1, right? Thinking of 6 divided by 6. Okay, so then you write your equivalent fractions. Okay, explain how you know that the fractions you found in part B are equivalent to 4/5. I could say something like, okay, I can say I multiplied 4/5 by the same number in the numerator and denominator. Denominator, which is like multiplying 4/5 by 1. And please make sure that you're writing this down. It's not for me. 4/5 by 1. Any number times 1. Any number times 1 equals itself.
Miss M, does that say liar?
Like,
Which is the liar?
So I know they are equivalent. Okay, I multiplied 4/5 by the same number in the numerator and in the denominator, which is like multiplying 4/5 by 1. Any number times 1 equals itself, so I know they're equivalent. But I just said equiv. I shortened it. Okay. Alright, once you finish writing that, we move down to question number 3. Look at the fractions in the table below. They can be written as equivalent fractions with a denominator of 12. What would you multiply each fraction by to make twelfths? Write that fraction name for 1 that you would use in that case. Then find the equivalent fraction with a denominator of 12. The first row has been completed for you. So each denominator needs to finish with 12. So you can just go over here and write 12 underneath all of them. Then you need to figure out what do you have to multiply your denominator at least to get to 12. Okay, so here they had to multiply 3 times 4 to get to 12. Okay, so their equivalent fraction for 1 is 4/4. And then they multiplied their numerator and denominator by both of them. Okay, so if we need to get from 4 as our denominator to 12, what do we need to multiply by? Pearson. We need to multiply by 3. So what's the equivalent fraction name for 1 if we're using 3? Pearson. 3/3. So if I'm going to need to multiply by 3, my equivalent fraction will be 3/3. Pretend I multiply by 3, and that would give me 9/12. And I will tell you, there's like 2 pages of this in the homework packet. So
So we have 2 pages.
I'm gonna try. This is like it. Once we're done with this, I'm gonna have you get into those packet pages, and then whatever you don't finish in class will be homework once we get back into that. Okay, 5, 6. How do I get from 6 to 12, Mira?
2.
Yep, multiplying by 2. So my equivalent fraction name is gonna be 2 halves. So I'd multiply by 2, multiply by 2. I would get 10/12. Okay, getting from 2 to 12, I'll need to multiply by Chloe, 6, which would make my equivalent fraction name what, Abby?
6 12.
So I've got 6/12, that's my equivalent fraction, and then my fraction name for 1, what would that be? 6/6. So your fraction name for 1, that's just what do I have to multiply my denominator to get to this new denominator? It's that number over itself. Fraction name for 1, that is just the same number over the same number. Okay, it says pick one fraction name for 1 that you used in problem 3. So this guys, how do you know that fraction is equivalent to 1? Okay. That was cool. Okay, I know that 3/3 equals 1 because 3, let's say I drew a picture. So 1, okay, because 3 small pieces in my drawing equal 1 large circle. Okay, so I know 3/3 equals 1 because 3 small pieces in my drawing equal 1 large circle. So 1/3, 1/3, 1/3, 1. So I drew a little picture. Okay, just for practice sake of things. Okay, if I gave you this guy, what's an equivalent fraction we could make? If I gave you 3/8, what's an equivalent fraction we could make from there? I don't want you raising your hand. Okay, Oscar, did you have one? Oh, Emmett, you got one?
6/16.
6/16. What'd you multiply by, kind sir? Multiplied by 2, which would make our fraction name for what? What would our fraction name for 1 be? We multiplied by 2, Emmett. 2 halves. Excellent. Oscar.
9/24.
8 to 9/24. What'd you multiply by?
3.
3, which would mean our fraction name for 1 is? If we multiplied by 3, that would mean it's 3/3. Okay, George, give me another one.
5, 12, 30.
12, 30 seconds. What'd you multiply by?
4.
Multiplied by 4, which would mean our fraction name for 1 is
4.
4/4. Asher?
1,872 over, 4,992, and then multiplied by 600.
So 624, 624. Senna?
This is at 3/8.
Mhm.
2,700 over 7,200, and then multiply 5 multiplied
900, so you'd have 900 900s. Excellent. Okay, so again, when you are writing your equivalent fraction, whatever you multiplied by, so we multiplied by 2 here, all you have to do, your fraction name for 1, you just take what you multiplied by and put it on your numerator and your denominator. Cool. What do you notice? Cool.
Did you say that
I'm gonna have you start it just so you don't have all those pages later.
if we didn't have the homework, would it be 2 pages?
I have to look at the packet. Okay, so just make sure that you keep in mind equivalent fraction rule relies on the MIP, that multiplicative identity property. So you have to be able to know that equivalent fractions go on that idea that you have this many total pieces out of, or you have this many pieces out of this many total. They're the same number top and bottom. It's equivalent to 1. That's how you get your equivalent fractions. All right, go ahead and close those up.